All right. I'm gonna go to my channel, pull up the link, pull up the link.
So you're trying to turn into a mini Joe Rogan.
Me, Joe Rogan,
Indian Joe Rogan.
Indie Joe Rogan. Ah,
Indian.
okay.
Well, indie too.
Indian
and
Joe
Indian.
Rogan.
Maybe
Yeah,
both.
I don't mind that.
You gotta get clips out of this. Make the hyper edited clips and put it all over TikTok and stuff.
Right, with like satisfying videos.
Yeah.
Have you seen those?
Yeah.
I think you should do that for Claros.
For Claros?
Yep. Like that's what it is. Like the last videos that you have made, that's what it is, right?
Well, the ones that have been popping off are more artsy, like Instagrammy.
Get
clips and put it all over TikTok and they're more, yeah.
They're more what?
They're more artsy and than like hype. You know.
Okay, so Anish, welcome everyone. We're gonna talk about Transistor to Transformer with my buddy Anish. Anish, would you like to tell everyone what you do and what you have done till now? And meanwhile, I'll just upload our stuff to everywhere.
Sick. Yeah. This camera. Hey, I'm Anish. I am the CEO and co-founder of Claros. It is an AI shopping expert / assistant. So, say you wanted to buy a new laptop, you instead of going through the whole buying process of, reading up a bunch of articles online or looking at Reddit, etc., you could just instantly go to Claros, and it'll know exactly what you want to buy, and it'll find the right product for you, using AI and LLMs and all these other cool new magical technologies. And yeah, so prior to that, I graduated from the Georgia Institute of Technology in 2021 with my bachelor's in computer science and my master's in 2022 also in AI. And I did a bunch of AI research back in the day. I've been really into NLP for a while. I also did a little bit in evolutionary computing. And other than that, like a couple other, software engineering roles.
That's amazing. If you see any problems with live stream at any point of time, just message me on WhatsApp somewhere, and I will just get to it. Oh, Pawan is here. What's up, Pawan? Good morning for you. I'll call you in some time. I was supposed to call Pawan at this time, but Pawan, I'll call you soon. So, the reason why I wanted to talk about this is because it's important to have bird eye view of like where whatever we are using, things that where did they came from, right? And where it is going. So I think computers and internet had like very deep impact on us in like last 50 to 70 years, right? So how did it all start? Because it has been 70, 80 years and we are just 20 years old, and most of the people watching are 20 to 40 years old, so they do not know like how everything happened. We do not need to go in depth, but starting from Transistor, how did we arrive to like now ChatGPT AI, right? Transformers are basically architecture behind ChatGPT and all the current latest LLMs or AI. So yeah, let's start with transistors, and then we can jump into whatever next subject we find interesting. Yeah, do you want to start with any initial thoughts of why this talk is important for anyone watching?
Okay, cool. So why should you care? Well, I think it's pretty obvious that computers have been one of the most transformational things in all of technology, or like just in all of history, right? Like I'd say the only other invention that's probably been more impactful than a computer has probably been the printing press. But yeah, like pretty much every single person in the entire world uses a computer in some way, shape, or form.
Yeah.
And all of our jobs, all of our lives, every single aspect of it has actually been impacted by a computer, and honestly by people living in the SF Bay Area, which is kind of cool.
Yeah. For context, we are in SF right now, which is birth of all the internet companies, I would say.
Yeah, all the internet companies. I mean, prior to that too, like going back to Transistor, the actual first, like, not first. I don't know if they were necessarily the first, but like the prominent semiconductor factory or semiconductor companies,
Mm-hmm.
and also the computers, the early video games, all that stuff also all started here.
Right.
So if you really want to go all the way back, right? Like actually, if you really want to go all the way back, you got to go back to World War II
Okay.
in Stanford. So
All right. Let's go to World War II and
Stanford. Yeah, there's no D.
Okay, there's no D.
Yeah, just Stanford.
Okay.
Yeah, so Stanford has a research. So Stanford is a pretty big research college, and they did a lot of research for the Army during World War II.
Okay.
And as a result of that, as a result of that, they attracted a lot of the early computing things. And by early computing things, I mean more of like, by computer, it wasn't actually like almost a transistor. It was like these little like vacuum tubes, essentially.
Yeah.
So a vacuum tube was, it used, it's like, imagine like a little light bulb filled with gas, and then I think it was like whether or not the gas was on in it or not. That's what caused
vacuum
vacuum
tubes. Okay, let's see. Something like this.
Essentially, yeah. So this is actually how they stored state.
State as in like 1
Yeah.
and 0.
1 and 0. So yeah, so
Okay.
everything in a computer is actually just insane orchestration of ones and zeros. Everything from, the bytes that are traveling across, a couple of networks to what's on the screen, all that stuff is all just ones and zeros at the end of the day.
Right.
So the more ones and zeros you can orchestrate, the more things you can do.
Why ones and zeros? Like let's talk a bit about that. Like why do we have to store information in ones and zeros and not directly into like let's say,
it's just insanely simple to build, right? Like, and when you store state in something, it's either there or it's not there. So if I wanted to say store like a number, so let's say I wanted to store the number. Okay, let's make it really easy, right? The number 0,
right?
because there's a 0, right? Nothing there.
Okay.
Number 1 is pretty easy.
Yeah.
Now there's something there.
Right.
But so let's just do that here, right? So a 0 would just be a 0.
Wait a second. Let's write here.
Okay.
Yeah,
so
0
is just a
basically
0.
0.
Yeah.
1
is just a 1.
We have some problem in nodes. 0.
Yeah.
1
is also just a 1.
Okay.
But now, how do you do it too?
Okay, so just to like make it even more simple, 0 and 1 means like, okay, there is a microphone here, which means there's something here, so we can call that as a 1 as a state. So that's 1, and there's no microphone, so there's 0. That's what you mean, right?
Yeah,
Okay.
yeah, exactly.
Okay. Now.
But then you can, by combining ones and zeros, you can build a bigger number. So a 2, for example, would be represented by a 1 followed by a 0. And without, so 2 would be, 1 and 0,
like 1 and 0.
Yeah. So like that, you can actually, and it gets just, the numbers just keep on getting increasing more and more as you go on.
Right.
But the point is, you can basically store anything as numbers, and in hardware speaking, it's pretty easy. It's really easy to build something that just stores a 1 or a 0. And that way we can pack a lot of these storage machines into a very small space. So first, initially, we had these vacuum tubes, right?
Yeah.
And that's what would store the 1 and the 0.
Yeah.
But that turns out that that's still pretty big, right? Like, that's like probably like the size of like a little film canister.
Right.
But I think it was invented at Stanford. I'm not 100% sure on this, but eventually someone invented a transistor, which essentially does the same exact ones and zeros storage, but it does it on a very small scale using electricity. So you can literally just capture the electricity and like force it into a little circuit.
Right.
That makes it be like, oh, this is a 1 forever, or this is a 0 forever.
Right.
We're not going to get into like how exactly that works yet.
Right.
But the cool thing is now that you can store this 1 and 0, right? And you can create other forms of data, like, other numbers from these 1s and 0s. If you get it small enough, and you can now with a transistor, you can actually pack all these together and do really cool things with it.
Right.
So the early computers were actually pretty simple. During the World War II days, they were used to actually just compute. I think they're used to compute like encryption breaking algorithms or encryption algorithms for war efforts, but and just do like simple calculations and stuff like that.
Yes.
Like and eventually though, they kind of reached the consumers via video games. So I don't know if you remember, but there's this company called Atari all the way back in the day.
Yeah, of course.
Yeah, they were one of the first people to actually create. Yeah, they created a whole bunch of these little games that were all really early computer based.
Yep.
But it was pretty cool. Like now we can use these 1s and 0s to have fun.
Right.
And the cool thing is these were some of the first computing devices that could actually fit inside someone's home. Like prior to this, there were these giant mainframe, big computers that are meant for companies.
Yeah.
Now you get it in someone's home.
Right. Okay. Just like quick zoom out from this.
Yeah.
Like 10 or 30 years would be like humans, like us, probably just us. Probably AIs are also watching this video, but not AIs, but humans as a species have been very obsessed with. Not obsessed, but this is requirement of just sharing information. So that's why printing press was a very big thing, because now we can just write stuff down and make multiple copies of it and spread the meme, spread the
I think
idea
the thing
across.
that matters is all the largest kind of transformations in history have, or at least in the information age, has been about how do I store more information in a smaller place. Originally that was books, then making tapes, then making CDs, and now it became those SSDs.
Yeah.
So there's like compressing of more information into a space, and then there's also the whole transmission of information, right? Like that's where the internet comes into it.
Right.
How do I send like a book's worth of knowledge from here to across the country? That used to be like I had to print a book, take the physical book, put it inside a cart, and then cart it over. But now I can just basically stream the information directly across a wire, or beam it through space and back down. So stuff like that. So pretty much, yeah, I think you could frame almost every single large technology shift as being one of those two kinds of advancements. And the thing is, LLMs are actually part of this too.
How come? How come LLMs are part of this?
Well, LLMs are really helpful for the storage of information. Now the entire internet, which used to be stored in like huge data centers, is now just stored. Effectively, it's compressed within the weights of like GPT, right? Instead of me having to like store all of Wikipedia, I can store all of it in the weights of a GPT, which is actually a lot smaller than Wikipedia.
In terms of memory size wise?
In terms of, I guess, just raw like facts and stuff, right? I can ask Wikipedia probably has somewhere in it like I don't know, like the whole history of computing, but I could also just query GPT and it'll tell me that too. So it's just a more compressed form of intelligence, or more compressed form of the knowledge.
What you're saying is, wait a second. What you're saying is, like GPT, like Wikipedia as itself, has lots of words written in sequence, and that as information, and then trained model. I think we are jumping a lot, but trained model. This is more efficient way to store the entire Wikipedia.
Exactly, yeah, because the Wikipedia is stored as natural language, right? So natural language is a lot. Going back to the binary, it's a lot of binary, right?
Right.
But GPT effectively just stores it encoded within its brain. So it's kind of like how if I sat down and I memorized a bunch of information, like it's probably the amount of information in my brain is probably larger than like a notepad.
Right.
Like, if I were to write down every single memory I have, it's a lot more efficiently compressed in my brain than it is if I were to write it down.
Yeah, I agree. But one before we move on to next topic, one quick point on that. Like the trained model will not have to retrieve information, and when you're retrieving the information, you cannot say 100% like this is a fact.
Yeah, that is one problem.
Yeah.
You know, the more it's compression is what we call lossy sometimes.
Yeah.
Yeah, so it's a form of lossy compression where you do lose a little bit of information
Right.
as you send it over.
True. Okay. Let's go deeper into it afterwards. But so from zeros and ones, we started making computers. Like we started doing the calculation. So first of all, it's just basic, just storage. Then using zeros and ones, you can perform multiplication, addition, all the
All the basic
operations.
things.
And if you can do that, you can just keep doing bigger stuff on
You need
top
a
of
big-
it,
yeah.
and it just continues. From there, we started making different applications of it. First one would be just like storing films, books, anything, like any type of media. Then performing communications between computers, right? And then games and stuff as well.
Well, games came before communication.
Oh, really?
So yeah, so basically the order progression was like these giant war mainframes, then video games, then I think this is the 70s. Then you start getting to like the PCs, you know, the Apple IIs, the Lisas, all that stuff. As that gets better, then you start getting like starts getting the internet, and then as that was. And then, as that was, the Apple II was like the first actual Apple computer that worked very well. This was like this was like the ChatGPT of the PCs.
1977.
Yeah, this is like when everything kind of started taking off.
Right. The vision of Steve Jobs was that like everyone should have computer in their home, and it has to be this small for
Exactly. Yeah.
it
Well,
to
he didn't
reach.
stop there.
Right,
Eventually,
yeah.
he would go even smaller until
Right.
you get the smartphone.
Makes sense. All right. I'm playing around with camera yet.
But yeah, it's cool. It's
So this was, what was the applications of this?
of the Apple II.
Yeah.
I think it had a bunch of stuff. So it shipped with a bunch of different like the programs. So like there was a drawing program. I think there was one to do taxes. The killer app though, the one that really started selling the computers past just hobbyists, was actually a spreadsheet. I think it was called, I don't know if it was called LibreCalc or it was some sort of early version of Excel.
Okay.
And that's when people saw how the Apple II could run that program, and it made running, you know, all these calculations a lot simpler and easier for like just the average business person, the average, you know, small business owner. That's what really started to sell it. VisiCalc, that's what it was called. Visic, VISICALC.
Ooh, okay.
That was this was the
This is interesting.
the killer app of the Apple II, and you could probably argue that it's what kind of set the whole computing revolution up.
I want to look at how. Oh my God. Okay.
Yeah,
This was before the UI.
Yeah, the GUI.
existed.
Yeah, the GUI was not really invented yet.
Right.
I think that's the coolest part, though, that a lot of people don't realize is everything had to be invented. It's like someone invented the cursor. Someone invented the fact that, like, you know, you just did this movement, right, where you had to pinch your fingers open to zoom in. Someone had to think about that is something I like have to do to zoom into a thing.
Yeah.
And then there's all these small little minutia that you don't really understand until you actually try to build something like this.
Yeah. Let's talk. Let's be let's be philosophers for a second. Like somebody has to make stuff for stuff to exist, right?
Yeah.
And making
I
stuff
mean, it depends on the thing, right? Like math already exists in the universe. Quarks exist.
That we need to discover.
Yeah.
Yeah. But physical.
In the context of technology, we do have to. We pretty much invent everything. At least everything that I can think about.
Yeah. True.
I think that's actually the definition of technology.
Yeah.
Things we invent. Yeah.
Things we invent, and literally everything surrounding us is technology. Everything.
Yep.
Right now, except our bodies.
Yeah, I mean that's the next frontier, right? A lot of people want to also try to build up our bodies.
Hmm.
And we already do that to some degree. We
We have
take
glasses.
we have glasses. We take
Yeah.
supplements.
Yeah.
We go work out to sculpt the muscles in certain ways, like plastic surgery.
What will be the next things after this? Do you think
Oh, after
Chris?
what?
Like in terms of body, as we're talking about body.
I think I really don't know. I think personally, I'm not as much of a fan of like invasive things. I think the thing about invasive things, they generally take a lot longer to implement or to reach the general public. But I do think there are a lot of external kind of body modifications that would probably be pretty cool to have. Like I could definitely see almost like an Iron Man type suit for soldiers to work out pretty well.
Yeah.
Or like better prosthetics. All the smart glasses type stuff you could argue is a form of like intelligence augmentation. Headphones, honestly, right? Like headphones kind of help us a lot too.
Yeah.
Um,
To focus.
yeah, to focus, to connect us to like other humans who
Yeah.
are hundreds of thousands of miles away.
Yeah. To disconnect with your current environment.
Mm-hmm.
Yeah.
So yeah, I think. But if you want to like talk about like, let me think. I really don't know actually. I haven't thought too much about what type of. I think a lot of the interesting thing about a lot of these like biomodifications is it's less about enhancing our bodies and more about trying to get our bodies to adapt to like the world to the other technology that we built up around it. Right? Like we created machines that are so noisy that now we have to have headphones to block them out. Or we I think like over time, I think there's been a couple studies that show that humans are slowly evolving to be more nearsighted because we don't actually need to look as far anymore.
Right.
So we also have glasses to help us with this evolution that's happening. Or even so, like the human body was not really made to work in an office all day, to sit in a sedentary position.
Right.
So we have to invent gyms and fitness
Yeah.
routines to fix that.
True. Small things like that, but I think within like next 10-20 years we'll have lots of preventive cares, as in like you are wearing your Apple Watch or something like Aura Ring or glucose monitor, or like lots of other wearables.
I do think wearables are definitely going to be they are already pretty big, and I think they will only continue to get bigger.
Yeah, but still in terms of hardware, I feel like we already have lots of data that we can use just to live better life. But we are not doing in terms of software, and probably because of lots of regulation, and probably nobody has looked at it yet. But if we start just looking at sleep data, heart rate,
Well, I think the
exercise
fundamental
data.
problem with a lot of these things is you actually need to want to care about it, right? Like for me to get an Oura Ring, I need to have already cared about wanting to improve my sleep.
Yeah.
I think a lot of people don't actually care about that yet.
The reason is that, like, what's the incentive of that? Let's say if I start tracking my
Well, I don't think it's a lack of incentive. I just think it's a lack of knowledge, or like just a lack of awareness that like.
I don't think so. It's not lack of awareness. I feel like it's lack of, like, I'm not getting anything out of it, right? If I sleep 5 hours or 7 hours, am I getting some analytics out of it? Like, hey, this is how I'm gonna feel. Like exactly the reason why this meeting didn't go well, or this decision that you made of eating this affected this thing. If I get like that specific analytics, I feel like I will get whatever device they're selling.
I see. Okay.
Right. I think general people.
So there's just so you're saying there's this disconnect between the data that's collected and then how that data is actually providing a valuable insight for the end user.
Yep.
That's cool. I mean, that's where AI could help come in and help out a lot.
Yeah.
Data analysis is actually pretty hard. That's why people would give degrees in it.
True.
So if you could have something in your pocket that does data analysis for you on your own data, or like on your own health metrics, that's probably a pretty valuable thing.
Makes sense. In terms of so let's go back to computers and transistors. So from transistors, zeros and ones, a way to store, most effective way to store an information. Now we are at computers. We are at like devices like this, where it has tons and tons of zeros and ones. We can What's up? Let's roll it again. Okay. Introducing Mihir. What's up?
Hello.
We are doing live stream right now.
Oh, hi.
Do you want to join
Sure.
right now?
Yeah.
Okay. Join it.
Hello, Anish.
Hey,
What's up, Mihir?
What's
what
up?
do you do? Just give us your like quick 1 minute introduction.
I'm here.
camera's here.
Oh, I'm
Okay,
here.
this is the camera. We just figured out how to use it. Thanks to
Ah.
Anish.
Nice. Yeah, I'm here. I technically I'm not graduated, but I'm almost graduated from Cal Poly.
Okay.
Yeah. Just in
Is Mihir
SF.
there already?
He's already there. Yeah.
Okay, perfect. Just in SF, he's working on a couple of very interesting projects, and yeah. So let me give you context of what we were talking about.
Yeah.
We started talking about zeros and ones.
Mhm.
Of course, we had to talk about
George Bull.
not George Bull, about vacuum tubes.
Yeah.
That's where it all started, right?
Yep. Fairchild Semiconductors.
Yep. What's that?
Oh, so those are the first people who made transistors happen.
Okay.
First
so,
company.
So from like vacuum tubes to transistor, that was the first company who made the transistors.
No. They were the first. They're the first people to do it.
Okay.
So the first person was this guy named Shockley,
Mhm.
who was a scientist who was kind of crazy. He was a very big supporter of eugenics, if you know what that is.
Okay.
And he worked with, I think, 3 people. It was Noyce.
Mhm.
I forgot the 2 other names, but essentially 3 guys. And then they stopped. They didn't like Shockley because Shockley was crazy. So they left Shockley and started their own company called Fairchild. Actually, it wasn't their own company. They joined a company called Fairchild. And Fairchild invented the transistor and
Okay.
actually commercialized it. But then they all left Fairchild and they all started their own companies. So one guy started AMD, one guy started Intel, and the other NVIDIA
Okay.
came much later. The other
Okay.
person started something called American Semiconductors,
Okay.
American National Semiconductors, something like that.
This was 1970s.
This is 1970, yes.
Okay.
The National Semiconductor is no longer in business, as you can probably tell.
Mhm, yeah.
The AMD and Intel still survive. So
Makes
that's the
sense.
story behind Intel and NVIDIA.
And transistors. Okay.
Mhm.
So we were.
Fun fact: my college school was is called Noyce School of Computing from
Okay.
Intel.
Okay. Interesting. All right. So we also talked about like why we need to store information in zeros and one. Is this the most effective way to store information?
Mhm.
And also we can talk a bit about quantum computing if you guys want to. If it's just too woohoo for now, we can skip
Yeah,
it.
we
I
can
don't
do it
know
later.
enough about it.
Yeah.
Okay, we can skip it for now then.
Why only 0 and 1? That's
Yeah, because quantum computing can store something in between
the thing is,
those as well.
any number can be represented as zeros and ones.
Yeah.
And why add a complexity in the circuits if you can only do it with like a simple switch?
Right.
And a 0 and 1 is literally on and off, and it's easy to do it for transistor. Then you can have actually people experimented with three-digit transformers, but it's just too complex for no reason.
True. Okay. Makes sense. Sounds good. Let's now talk again about AI. So, okay, we talked about transistors to like latest computers, right? Other things are not that interesting. We can talk about everything in detail, but I want to jump back to AI. So, transformers are current architecture of GPTs and all the LLMs, right? So we can talk about that. And before that, let's go back to whatever the previous forms of AI was. Like before this, it was neural networks. Before that, if you want to.
Symbolic,
Maybe we should not go much into like the dates or who invented it or like those kind of things.
Yeah.
But why that was like more of like knowledge of why something worked or why something didn't work.
Yeah.
What was the philosophy behind the people who were creating it? Why they
Yeah.
were creating it? What was the use case they were tackling? So I think like what's the name of this guy? John McCarthy or something like that.
John
McCarthy?
McCarthy.
Yeah.
Yeah.
He was the
was
first one.
Founder of
who-
AI. Yeah.
Well,
He
also
made
Marvin,
Lisp.
also Marvin Minsky.
So those guys, they were
Yeah.
the symbolic AI guys, and
Yeah.
they believed that intelligence is nothing but a complex set of rules and logic. And if you can emulate intelligence through essentially logic, right? And John McCarthy started that with inventing Lisp. And the thing about Lisp is a language where it can very easily change itself. And the thinking was that if you have a language that can change itself, you can probably get some sort of intelligent behavior. But there's another and then
Sorry, I just zoned out. Sorry.
and then there's the other side. So these guys were the main guys in AI until another one was Gerald Sussman, who did a lot of research in metaprogramming.
Okay.
These were the main guys in
Okay.
AI. But then there were some guys on the side who were like underdogs. They were the neural network guys. They believed that the best way to learn to actually do intelligence is to actually go through biology. And they would read neuroscience papers rather than mathematics papers.
Okay.
And they would be like, okay, how does the brain work? And then when they figured out that our brains are made of neurons,
Yeah.
they were like, okay, why don't we just emulate that on the computers? And they did that, and they actually got a lot of. They were made fun of. They were actually not allowed to. They were not invited to any conferences because they're like, who are these guys? Symbolic AI is where it is. We need humans are of course logical, so like intelligence is logical. Meanwhile, if you look at what a neural network is, it's just a function. It's a mathematical function.
Right.
It seems that it shouldn't work because
Right.
all it's doing is a very simple calculation.
Yeah.
Compared to like symbolic AI, which is like every single rule, if you have this, you do this. If you have this, do this.
Right.
So people thought that's how intelligence will happen.
Wow.
So these guys were made fun of, and then the big reason why they were made fun of is they're like, you need so much computing
Yeah.
to actually train the neural network. That will never be feasible.
Right. So this was probably 1980s.
80s, exactly.
Yeah.
So they were right in the 80s, but what they didn't see is Moore's law and like how computing would follow. Back to Moore, the guy who made Intel.
Yeah.
He said that transistors would shrink in size by 2 times every year.
Right.
So if your transistors become
Yeah.
small every year, you can fit more transistors, and then for
Yep.
more compute. Is not true now, but that's what he said was
Right.
back then until
It's
2015. It's
Okay.
not true now.
Not anymore.
No, it's slowed
Really?
down.
Oh, okay.
Our transistors are so small that they're literally made of like few atoms now. You
Yeah.
can't go more small without just like
Breaking laws
Yeah,
of physics or like having very good advancement.
from what I've heard and read, the issue is something called quantum tunneling, where the electrons which are trapped inside the transistor just jump across the atoms.
Okay. So it's yeah.
But anyways, I don't know much about that, so
Okay.
I won't even go in there.
Sounds good. So they started developing neural networks.
Yes.
And from 2010 to 12, I think by 2010 we had good computing and we had enough data, right?
I think another big thing that happened for computing was distributed systems. Instead of just training on one computer, we figure out algorithms and like techniques to train on multiple computers.
Right, GPUs basically.
No. So like instead of just running on one CPU, you run the same thing on thousands of CPUs and like transfer the learning back. That was actually a very important lesson in like how do we spread like compute across many things. So you had MapReduce, which was a way to like process data across like many computers.
Interesting. Okay. And Anish, do you want to talk about computer vision? Were you keeping up with computer vision on like 2012, 14, 16? Not that's too early. Maybe even
No,
later.
actually,
That's when the deep learning revolution
Yeah.
started.
True.
Yeah, the very first things in the deep learning revolution was actually this data set called ImageNet, and then a network
Yeah.
was called AlexNet,
Yeah.
named after the guy who made it. And the thing about ImageNet was it was basically just a common object. It's called object classification. So you would get a picture of a cat, and then a neural network would try to guess whether or not it was a cat.
These are all the objects that ImageNet had, and the basic computer. Okay. Basically, it had all the objects.
Yeah, just like very common objects, dog, cat,
Right.
net, random stuff like that. So the thing about that was where remember when Mihir was talking about how the neural network guys were kind of going up against the symbolic guys, and they were losing. Well, this is when the breakthrough happened. The GPUs were starting to pick up because they're pretty good for running video games on. You know,
Oh yeah,
you could render things pretty well with them.
true.
So I think it was at Stanford or University of Toronto or somewhere, but they had this idea like, oh, what if we could take these computers that are made for running video games? They're essentially the same things as running our neural networks on. So like, what if we build a bigger neural network than anything we've ever had with these computers? And then they did that, and then trained it on AlexNet, or trained AlexNet on AlexNet the model on ImageNet the dataset, and it turns out it performed very well. It like beat all of the different records, and it kind of led to like the first, I guess like the first kind of deep learning like hype. You know,
Right.
like oh,
Yeah.
we could actually like run these like image classification things on these random video game computers, and they
Yeah.
work very well.
Right.
And this is kind of like how, so over the years from like 2012 to probably like 2017ish, everyone would keep on making upgrades or making improvements in this image recognition domain. Like, so for example, now we can tag the images within it, like draw a little bounding box around it. We can obviously like just classify more things better. We can like segment it better, so not only can I draw a box around it, I can actually trace your outline.
Yeah.
All these different little like minor improvements,
Right.
as well as making it smaller, faster, better,
Right.
all this stuff. And this was kind of like the state of computer vision up until 2007, up until actually probably like 2020ish.
Yeah.
Because
18,
2017,
19, yeah.
because that's when the Transformer took over ImageNet. But the actual story of the Transformer starts in 2017, when the Attention is All You Need paper dropped.
Yeah.
It was a so people so
Can continue.
Attention is essentially this like a neural network is kind of like a Lego stack of different blocks. And a lot of the improvements is like what kind of block you're stacking on this
Right.
Lego set.
Right.
So the image stuff used all these kind of blocks called convolution blocks. But these guys at Google thought, like, what if we could use this block called an attention block instead? Actually, like, what if we just threw away all of the other blocks, the convolution blocks? What if we only use the attention blocks?
Yeah. What's up?
Oh, am I interrupting?
Yeah, we are live on YouTube.
Okay, well, Kanye is starting in like 20
Now?
minutes. In 25
What's
minutes.
up? What's up? I'm not coming.
You're not coming?
No.
Okay. You're gonna just be here until I come back?
No, I'll go back home.
My backpack's here.
I'll take your backpack.
Okay, can you take my backpack? Alright.
All right, that was Kiran. He is going to Kanye's show.
Damn, no.
No, it's okay. No worries. It's a chill stream. So what we were talking about? We were talking about like how Google guys just threw away one box. I forgot the context. Attention is all you need.
So everyone used these one types of Lego bricks to build their neural networks. They decided, like, what if we use this other type?
Right.
Called attention blocks. And it turns out that worked really well. Especially for their task, which was machine translation, or essentially, how do I convert text in one language, like say French, to text in another language, say English. And yeah, it worked amazingly. And then that's where this new like NLP, that's pretty much the starting point for the LLM.
Right.
They were still very small back then. Like, I think I forget how big the actual model in their paper was, but Google, like after that point, Google, OpenAI, a bunch of other people started making similar copies of models, and everyone would tweak the architecture in certain ways, until eventually, Google kind of went for this one architecture that was really good at understanding, which makes sense when you think about what they could use the model for, right? Like if you had a model that could understand text very well, it's pretty good at understanding a search query. You could build a really good search engine with that. And actually, that same model, the eventual model that they got from this paper, after like a couple derivations on it, that's the model that they use for Google search now. I think. Like, no one really knows for sure.
Mm-hmm.
But OpenAI went in the other direction. They're like, yo, what if we got it really good at generating text? So that was GPT-1.
Yeah.
They just get it, like, it can generate, I think it could probably generate, like, a sentence pretty well, which was still really good for the time. Like, prior to this, the best we could do is probably, like, you know, like half a sentence or something, because it was just very hard. But they got a sentence which is really good. Then they were like, yo, what if we just take this and we scale it up a little? Let's call it GPT-2. We'll make it, instead of it being like 100 million parameters, we'll make it 1.5 billion.
Right.
And turns out that generated not a sentence, but like a half a page. That was really cool.
Which was making sense.
Making sense. This is the first time you've ever been able to generate a paragraph of text that like actually sounds legit.
Right. When you show it to someone, they cannot say if it's written by AI or not.
Exactly. Yeah. There's this famous example of like.
It's a Turing test.
Yeah. Turing test. Oh yeah.
Well,
but not really. Right?
Yeah, Turing test is slightly different. It's more like a chatbot thing.
Yeah.
The thing that kind of went viral for them was this. It was like this fake article they generated about someone in Peru, like using llamas to discover Machu Picchu or something. It was something like that, yeah. But it was pretty. It was pretty cool.
Interesting retrospective.
Yeah, but there was one problem with GPT-2 still. You still have to train it on anything you want it to do, right? So if I wanted to generate, a paragraph about, if I wanted to do like text, if I want to like translate XYZ into like French or Spanish or whatever, I need to train the model. I need to train the model to do that. So that's pretty expensive.
Okay.
They kind of left that to the side for now, and then they said, "Yo, what if we train it even bigger? Let's call it GPT-3. We'll make it even bigger now." And that was May 2020, and that was where things got really interesting, because they noticed. So one, of course, like it's bigger, so it's better at just all the tasks.
Yeah.
But what was really cool was you no longer actually had to train the model to do tasks. You just tell it like, this is what Spanish looks like. This is what you just tell it like, for example, a couple examples of what you want to do.
Right.
Like here are some of my tweets. Generate me more tweets like this. Here are some, here are some examples of my writing. Generate more writing like this. Here's some examples of the code. Generate some more code. And it actually picked up on it. The same model, with no changes, somehow could understand all these different things and then just output things similar to it.
Yeah.
And they called that few-shot learning or transfer learning.
Yeah.
And that was insane. The fact that one model could do so many things at once. And then that's when things really started to take off, because people realized like, oh, you could actually build really cool companies off of this, right? If I could give it examples of like past dialogue, I can make my little chatbot that says whatever I want it to say.
Right.
Or I could, if I give it examples of React components, I could get it to generate, front end, basically websites like on the fly. That's pretty cool. Or just even something as basic as like a language translator.
Yeah.
It could translate language for me in real time if I give it the text in real time.
Right.
I think a big thing with language translation there was like, if you look at old Google Translate, it would translate word to word and not actually have an understanding of the underlying thing.
Yeah.
I think what was big with transformers was they actually understood what was happening.
Right.
And what linguists thought linguists thought there was an impossible task for anyone to do.
Right.
and they
That's
had
what
this,
everyone thinks.
no,
right?
they had a massive theorem to prove that it is impossible for you to mathematically predict what will happen, because blah blah blah. And then the AI guys came and disproved a lot of linguistics. So that was a big disruption there.
Okay. Yeah, and in hindsight, we can just see it, right?
Yeah.
How wrong they were. What's both of your opinion on, like, within 2 to 5 years, except software engineers, we'll not talk about them, except software engineers, which other jobs can be, literally replaced? I don't see, why would someone need translator today, right? For very important documents, if it's something related to lawyers and stuff, sure. But if you want to just talk with someone who is speaking Spanish, you can just do it in Google Translator, right? And they have really good features of a real-time talk and stuff. So what are the other things?
I mean, when was the last time you used a human translator anyway?
Yeah.
I have company in France, right? So couple of time I have paid a lot of money like
Mhm.
500 euros, 1,000 euros
I still think in
just
those
to
kind
translate.
yeah, I think in those kind of cases, well, maybe their job would probably be gone.
Yeah,
But I like overall in terms of raw number of jobs,
yeah.
it's definitely overhyped the amount of jobs that
Mm.
AI would replace. At least right now.
At least for the short term, yeah.
Yeah, for like 2 to 5 years. Yeah, makes sense. Like for the infrastructure to exist, to use of the AI as well, right?
Well, funny
yeah.
enough, I actually don't have enough computers and enough electricity to have. If you want to have everyone replaced, we just don't have enough electricity.
Yeah, for
Uh,
sure.
Funny enough, we actually are running out of transformers. Just a different kind of transformer.
What is that?
Oh, it's a transformer, something that converts like AC electricity to DC or DC to AC. Right? I'm
Yeah,
getting that wrong.
exactly.
You're getting that right. And they take like years to make, and the
Hmm.
contracts are like 5 years long. And no one predicted like this massive surge of electricity required for electric cars and GPUs. So we are running out of transformers, and it's going to take 5 years for us to build them.
Wow.
So
So,
yeah, that's why you actually see a lot of data center companies actually even buying nuclear like trying to like go make their own electricity using nuclear reactors.
wow. I didn't know that. That's crazy. Like, so, it's slowing our pace of innovation. It's slowing our
Not yet,
pace
but
of,
experts are predicting so.
okay.
Yeah.
So, I mean, GPT-6 might come like 1 year late, right? Or whatever it could
I mean,
come.
there's other like there's a whole host of different things
Yeah.
too, right? Like a lot of things follow like a scaling law they call it.
Mhm.
Essentially, like as you grow the model,
Uh-huh.
it's supposed to get better.
Right.
But at some point, you are going to hit a point where you can't actually make the model bigger. And the thing was, in all the different past types of architectures, we hit that limit pretty quickly.
Hmm.
Of like you can't scale it bigger and get like a reasonable benefit out of it.
Right.
But for transformers, we just haven't hit that limit yet. There probably is a limit. We just don't know like what it is, and we haven't hit it yet, so we don't need to worry about it.
Mm-hmm.
Anish, what do you think? Do you think LLMs are smarter than a mouse? Because mice are
Depends-
pretty smart.
It depends on what it's
How do you define smartness?
like if
No,
you
no,
want
no,
if you want to
yeah.
do like a maze navigation kind of thing, probably.
Yeah.
I think you could probably I think they could probably be as smart as a mouse.
Mhm.
Hmm.
It's the hard part in that is like doing it's like the latency, right? Is the hard part for that.
Yeah,
Like
yeah.
giving it the ability to do things that a mouse could do
Yeah.
is pretty hard.
Yeah.
That's the trick there.
What do you mean, like hardware, physical
Hardware,
wise?
yeah.
Yeah,
Hardware,
okay.
physical, like, oh, let me see, like, if I'm a mouse, right, I want to go through a hole in the wall, or I want to chew through a wire. Like, okay, let me go, like, how does an LLM chew through a wire? You need, like, that's the harder part
Yeah.
right now. Than, like, actually
Yeah.
thinking, oh, I need to chew through a wire.
Right. But I think judgment wise, it is
I think
smarter than.
There's
mice.
also different sensory inputs that a mouse has that an LLM doesn't have. Like, an LLM can't smell, an LLM can't. Yeah. I mean,
Yeah, it's just, yeah.
No. I mean,
Yeah.
I recently read this paper where they actually gave I think an LLM, I don't think it's LLM, some kind of transformer, chemical information, and it would classify smells.
I can
based
see
on the-
that working well.
Yeah, so I mean, and they used a sensor to get all the input, and then so they had like a model predict like smelling, I guess, which is I guess the only thing that's left is touch.
Yeah, touch is also pretty easy too, though. So
With all this
it's just
VR
doing it
haptic.
latency.
Yeah, with all this VR haptic gloves, right?
Can they identify texture?
Texture,
seems hard.
probably. I think
Yeah,
I don't.
it's not
Okay, I
hard.
don't see. Yeah, I don't see why it would be anything harder than something for like say protein folding.
Yeah.
So
Mm.
if you can do something to do protein folding, you can probably do something to do texture.
Has protein folding problem that we solved already, has it helped in like real world?
Yeah, I'm pretty sure the COVID vaccine was
Yeah.
part of the reason why the COVID vaccine happened as fast as it did, because it happened remarkably fast compared to most vaccines.
Yeah.
At least in the United States.
Yeah.
But
India as well, bro.
No, but
I mean,
India used a totally different vaccine.
Ah.
India used something called an attenuated vaccine. I'm not an
Okay.
expert by any means, but they actually used dead virus. They did what
Okay.
the US did is modified RNA, mRNA.
Okay.
That's a whole
Makes
different,
sense.
completely different type of vaccines.
Okay.
Yeah.
Makes sense.
so yeah, the only reason we were able to do that was
It's because of protein folding problem
Exactly,
was
yeah.
solved. Okay.
Yeah.
well, I don't know if it's I wouldn't know if I would call it solved.
Okay, but it's much
there's
better.
been yeah.
Yeah. Okay. What are the other challenging problems that if we can solve them in like next 5, 10, or whenever, we will open up a new
Fusion.
front? Yeah, fusion. No,
Uh,
in terms of like AI.
In terms of AI.
Oh no! So
Even in terms of AI. Okay.
So I was actually this was a very interesting paper by
Hmm.
Google, and they I think partnered with ITER. And if you know what ITER does fusion research.
Huh.
A lot of countries come together and do research, and the way they wanted to solve fusion is they have a ring like a
Mhm.
donut, and they have
Okay.
plasma in the center. And currently, like they have a very simple algorithm to keep the plasma in hold,
Hmm.
but it's the plasma is very unruly because it doesn't want to be in the donut shape. It's random. So they used Google's RL system to actually keep the plasma under control and drastically increased efficiency.
Hmm.
And I think I mean AI's help according to according to the paper I saw is like it might like bring down the time we need to get to fusion
Hmm.
by a lot.
That will be great because more electricity is just
Oh yeah, I mean that
good.
once you do fusion, you just have infinite. I mean near infinite electricity.
Wow. I mean, what will that look like? Like, everything is basically just like we accelerate. We were talking about electricity problem, right? For that, like we accelerate
We still
everything.
need transformers.
Yeah, but I think we still with that. If we
I
have
know,
one thing that is infinite, we can accelerate everything, right?
We can figure it out, but I'm just
Yeah.
saying, like, the transformers, we still need them.
Yeah. But what are they made of?
Transformers?
Yeah.
We can make one pretty easy. Like it's just like I think it's just two inductors.
Hmm.
So an inductor is so this is the actual electrical signal for a transformer, like this.
Uh-huh.
I think
Yeah.
it's literally you just do this. You build a coil of wire going one way, and you build a coil of wire the other way.
Hmm.
And there's this electrical property that I guess nature has, is that when you put wires in a coil and you run an electrical current through it, it creates a field, and then you
Okay.
put another coil next to it. That field will then cause the same effect in the other wire.
Right.
So like that, you can convert AC current to DC current.
Hmm. Okay. All right. Interesting. So it's not that complicated to make.
No, but at an
at
industrial scale,
though.
it's big. Yeah,
Right.
when you
Plus
have
you get
massive
small.
one handling like gigawatts of power, that's hard.
Right.
Because if those blow.
Yeah.
Yeah.
So,
Will we ever run out of materials to make this?
No.
What are these made of? Like in terms of materials?
I mean, eventually you will.
I mean, yeah, but like not Indian soon. Like platinum, I'm guessing. Silver.
I have no idea. I've
platinum?
never
Yeah, I don't
made
know.
a commercial level
Yeah,
transformer.
Yeah.
Okay.
Yeah.
Some kind of metal, some kind of steel.
What are uh,
Probably not in Google Images.
I will change it. Industrial transformers
They made
are
of GPUs.
made of. Yeah. Okay, so this is how it looks.
So
that-
yeah, have you seen those things?
Yeah.
Those things on the road or
Yep.
yeah, those are massive transistors. Like what that thing? Not transistors. I said
Transformers.
transformers. Yeah.
Everything.
Oh, interesting. Silicon. Everything needs silicon.
Okay, so I think we can still figure it out.
Oh no. Yeah, the issue is the time to make it, transport it,
Right.
attach it. Those things just take time.
I think
It's not
the
that
larger
big,
concern is actually
Yeah.
more so like, is there demand for running an AI model?
Hmm.
Like all these things include demand projections
Yeah.
that might not necessarily happen. Like, so, like I think that's actually the more interesting thing is, what can you still use AI for?
Hmm.
Because even though like the only actual product that's probably worked really well is ChatGPT.
Hmm.
And Midjourney.
Midjourney kind of, but like at the end of the day, what does Midjourney do? It's just
Not
kind of
very as useful as ChatGPT.
exactly.
Makes
You
sense.
go to a
Yeah.
person on the street, they know what ChatGPT is, but
Yeah.
that's about it. Out of everything that's come out of this new wave,
Yeah, I mean ChatGPT is much more useful than Midjourney, but
Mhm.
Midjourney is like 10% useful than.
but
ChatGPT,
Midjourney
I
isn't
think.
enough to cause a transformer outage or
No.
transformer
It's all
slowdown.
ChatGPT.
So I think, but that doesn't mean that there aren't any use cases. I do think there are still tremendous amounts of use cases that we still have to discover, and products that we still have to discover to kind of meet this expected demand curve.
Right.
So if someone were to decide what to work on right now,
Mhm.
I would say, while it's still probably helpful to work on something like Fusion, there still is a lot of easy gains to be made just on
Yeah.
working on cool AI products.
Right. Yeah, that's what I'm thinking
And
about,
not to
like,
mention,
a
I
lot.
think, I mean, AI ultimately, if AI it does pan out,
Yeah.
it's the highest leverage because it's like you can use the leverages there to help in fusion, like because that's what happened. That's what we saw.
So
Uh,
AI is still something that everyone should work on, regardless if they care about money or anything, because AI.
I think people should work on what they want to work on.
Yeah, there's
If
But
you really want to work on Fusion, I'm not going to stop you from working on Fusion.
you should work what you enjoy. What you enjoy.
That's true. But let's say somebody has no preference. They want to do something which moves technology forward in like the best, like their effort to moving technology forward.
I used to
that-
think the same
yeah.
way,
Mm.
but until very recently. But then, um, someone explained this to me, and I kind of realized that like you can actually there's very rarely one dominant thing that'll
Mhm.
move the world forward.
Mm.
It's almost always like a collection of different things. Like for example,
Yeah.
take Elon Musk.
Yeah.
Right. Like he has the same mo. Like I'm gonna make technology that moves the world forward, and he's involved in the robotics and self-driving cars and AI and space exploration, and, satellite internet, like all these different things, all of which actually do help move the world forward.
Yeah.
So I think, just work.
On
The
whatever you
other,
find
the other part
interesting,
of this equation that you want to do is like, sure, what moves the world to the largest degree, but it's also like how quickly can you start working on it?
Mm.
If you want to work on Fusion, like you have a long amount of time,
Yeah.
probably like 6 months at the very earliest before you can actually, if you're starting from ground zero, you know absolutely nothing about Fusion.
Yeah. Yeah.
Before you can actually start doing things.
Right.
With a lot of these AI things, you can probably get something really good by the end of this week, if you really put effort into it. So I think that's the other like, if you were to make it into a math equation, that's the other factor not a lot of people are, thinking about.
Okay. One quick question on a follow up on that. If you were not working on what you're working on right now, both of you, especially in AI, what other thing would you work on?
Especially in AI, so
Yeah.
don't say anything in AI.
No, it has to be in AI.
So you're
Like-
saying say another AI thing that.
Yep.
Okay.
That you would work on. Or you as well. Me.
For me, I have always wanted to work on a concept called digital Aristotle, which is if you know Aristotle was
Yeah.
tutor of Alexander. Alexander was,
Steve Jobs, right? Have you seen that clip?
no.
Okay. Like that was literally. Yeah, but you continue. I'll find that clip if I can.
So the reason why Alexander was Alexander, people say, is because his tutor was literally Aristotle, and I think I've always wanted to build essentially a digital Aristotle, which will
What's the spelling of? Yeah. Okay. Yeah. Makes sense.
which will actually let anyone learn anything,
Right.
and you essentially have your own tutor who get.
In this 1985 speech,
Okay.
Steve Jobs essentially predicted before it became.
My hope is that in our lifetimes, we can make a tool of a new kind, of an interactive kind. Someday, when the next Aristotle is alive, we can capture the underlying worldview of that Aristotle in a computer. And someday, some student will be able to not only read the words Aristotle wrote, but ask Aristotle a question.
Question. Yeah. Yeah.
I
think-
mean, this is similar, yeah, but I actually
Yeah.
didn't know about this. This is pretty cool.
Right, and this was 1985.
Oh yeah.
So yeah, that's very cool. So okay, how would you do it differently? Because now nobody will question you for this. Yeah, definitely this is possible. We can do it. How would you do it differently?
I don't think we're there yet, but a good start, good start. I was thinking was is a do you know what a flow state is?
Yeah.
So essentially, if you're in a flow state, you will do it. You can do the same thing for no matter
Right.
for a long time.
Yeah.
And
As long as you are in flow state.
exactly. And what keeps you in a flow state, right? So this is graph, which is this is how challenging something is,
Yeah.
and this is how challenging something is, and
Rewarding.
reward. No, I don't think it's reward. I forgot what it is. There are two axes. One is it boring or is it hard? And the other one is, what's the other? Do you remember? Let's look if you can look it up.
What should I look it
Flow
up?
chart graph. I think I keep forgetting what the graph looks like, but it's a good graph.
Not
no,
this flow. It's
flow state.
flows.
It's actually not a flow state. Yeah. There we go.
Challenge and skill.
Yes, there we go. Challenge and skill, right?
Hmm.
So if I can choose, can they see the screen?
Yeah. Here.
Oh, okay.
Everyone
Yeah.
can see this.
Let's say now you're trying to solve a math
Wait a
problem,
second.
right?
Let
Yeah.
me. Okay. I'll put us here. Decrease our size. Okay. Yeah, we are trying to solve math problem.
And yes,
Yeah.
I'm trying to do this problem, and the reason why I feel like most people stop, don't like math. I don't think they can see them.
Yeah, we can see it.
Okay. I think the reason why most people, there are two reasons why people would stop liking math. Math is famous for people not liking it. So, So let's say there's a student who is not who doesn't get concept who didn't get the concept for some reason. Maybe he was
Right.
sick that day in first grade,
Yeah.
and for some reason that led to this domino effect where he just doesn't understand the fundamentals. So he'll probably be somewhere behind in the skill, right?
True.
So that's like less in skills, but it's very challenging. This problem is super challenging for him, and he won't never be in flow state because he's like, oh damn, this is so hard. He'll be frustrated and then stop doing math
You
practice.
have to meet where he is in terms
Exactly.
of skills.
So
Yeah.
you have to, if you go down and you reach here where you give them a simple question, and you keep giving the question over here, then the person's interested. Now that the person's more skilled now, so as they do more problems, they get skilled, and now they're bored, and now they have to go back up again. They have to whoops. So you have to keep doing this dance, and I think if you keep someone in this flow state, you can actually make them addicted to math problems.
Yeah.
I
Just
mean,
like chess, right?
Just like TikTok.
Yeah, anything.
Anything.
Yeah.
Like you can actually make someone addicted to anything because that's what flow state is. It's actually it's an
exactly
addiction.
like TikTok because it tunes into
Yeah.
your interests very fast within like
Exactly.
1 or 2 days. Yeah.
Now I think LLMs have a very decent understanding of math problems and how hard they are.
Mm-hmm.
And I think they have also a very good understanding of whether someone is getting better or not
Okay.
through what in context learning that Anish mentioned.
Mm-hmm.
And I think maybe with some fine tuning, you can have a tutor that will always assign you the perfect problem, and
Depending on where you are in
depending on where you are, and make it super enjoyable so that you'll never stop studying because at that point it's not even studying. And I think this is possible with today's LLMs. I hope if they become smarter, very smart, we might be able to have like true digital Aristotle.
This is amazing.
Now the question is that if the AI is that smart, then do you need education in the first place? But that's a whole different story. So
I don't think that's actually enough though.
what?
Because when you're trying to get a kid to do math problems, you're not just trying to keep them in a flow state. You're actually competing against all the other things they could possibly be doing.
Oh yeah. I agree. I mean, it's not gonna be this magic bullet where you give it and then they'll prefer this over TikTok, like for sure, 100%. But I still think it's better than
Did you guys saw the video that
in a
someone
classroom
was?
setting.
Did you guys saw the video that Kim Kardashian teaching algebra or something, right?
Oh
So-
yeah.
You haven't seen it?
It's like a deep fake. It's a deep fake of Kim Kardashian teaching algebra.
Yeah, and people are liking that shit.
Yeah.
Okay, so we have 4.
But are they actually learning math through it though? I think that's the more.
I think they will
important question.
learn at least something because they are. But okay, let's not go deep into it. Digital Aristotle that teaches you stuff, right? What would you make, Anish? And one quick thing, we just have like 4% battery left, and I do not have any plug to put
You want me to
battery
get
on.
you a charger?
No. We'll finish up the stream after this.
What is this?
What?
You have a charger.
I have a charger, but we do not have any Type C left, and this is
Oh.
Type C, so that's why.
Right.
It's okay. This will be a great end of the stream.
Okay.
With like 4%.
I think probably I would want to work on a CAD software thing to
CAD software thing.
Yeah, automatically.
Okay.
I think it's kind of a hard vision to say, but I want to help people manufacture anything they want custom made. So I think one hard part of that is people don't realize the extent to which they can design something. So there's kind of like automatic CAD generation or automatic like a code assistant for CAD design. So you just say, hey,
Text to
hey,
CAD.
yeah, you know, hey,
Yeah.
CAD buddy, can you make me a new bench?
Hmm.
Because instead of going to IKEA and buying their ugly bench, you can basically just have like your, you know, a neighborhood CAD, you know, like a neighborhood CNC machine or neighborhood 3D printer, just like print you things you need or manufacture things you need at a very small scale, and make it custom made. Because
Amazing.
yeah,
Why this?
I think I don't know. I just think it'd be. I think a lot of people would want something like this. It's just very hard to do. I don't. There might be other reasons for that. Like maybe it's just economically not feasible or something. But I do think like even still like it's probably like I would probably pay like for example, if I were to get a chair, I would probably pay like say 30% more for a custom made one over you know a generic one.
Hmm.
But it's really hard for me to make one, so I just don't.
And the problem is CAD there? Like you do not know how to
Well,
design it?
I think there's a lot of problems. One part is the CAD, one part is the sourcing, but like all the other problems, I think are solvable or like pretty close to being solved already, like logistics and manufacturing stuff like that. I think I think one easy thing to do is the CAD portion. You just like make it easier for people to design things.
Yeah.
I think that would be pretty fun.
I think that like both of your ideas are very
Yeah.
very good in
Yeah.
terms
I
of
mean,
like
there's this other
yeah.
idea I've been having a lot.
What is it?
I'll make like a little AI field journal, so for kids. So imagine like a little book almost, and then the book has a camera on the back. So if you're a kid and you want to like learn more about nature, you can just like take the book, point it at like a frog, you say. It'll take a picture of the frog, realize what kind of animal the frog is, and then kind of like
Gives you information
generate like a
about
page
it.
about it.
Yeah.
Like, you know,
Oh,
here's
wow.
a frog, here's all the different, you know, cool things about this specific
Anish, you
frog.
should pivot.
And you can almost like, you can like collect frogs. Or not collect frog, collect anything.
Yeah.
It's like a Pokédex.
Yeah, essentially, yeah. Like, I want a Pokédex for the real world.
Okay.
Anish, you
Sorry.
should pivot.
I mean,
No,
it's,
no.
I'm
that's
just joking.
not
I'm
a-
just joking. I'm just joking, by the way.
I don't think it would make $1 billion, but it would be something cool.
Okay.
No.
So are you saying Claros will make $1 billion?
I think so.
Yeah.
I think
Okay.
good. I think
Or
it
more
could make.
The next Amazon.
You know what
Yeah,
is
I think
cooler
at least-
than $1 billion?
Well, I don't know if it could be. It's very hard to become a $1 trillion company. You need to make hardware to be a $1 trillion company. I've never seen a $1 trillion company that hasn't made hardware before.
But it's like if you're looking at
If
like
you're
10
but-
years.
If you're at a 10-year, yeah, I think
I mean,
if you're a $10 billion company, it's probably not. It's not that hard.
Are you
to-
adjusting for inflation?
Yeah, exactly. That's what I'm saying. Like if you're looking at
Oh.
10 years window, I think.
And if the Fed just
like,
prints money, then like. you
I
know.
think-
I mean, yeah. I just wanna.
How many companies are there with $1 trillion market cap?
Three.
Just
Yeah,
three?
Probably three. Probably Apple.
Nvidia, Apple,
And Aramco.
uh,
Actually, Microsoft, so 4. I don't know if Google and Amazon are not really, right? So, They're
but-
four.
Yeah, Microsoft, Google, Amazon, Nvidia leading the pack.
Trillion? This is Aramco. People forget about Aramco.
I think this one might only be talking about tech companies.
Okay. Yeah. Saudi Aramco is 3 trillion.
6 companies. Yeah. Okay. So yeah, that's true. It's very hard. Yeah, Saudi.
But yeah, one milestone at a time.
One milestone at a time. Let's approach for billion first.
Yeah.
And then we'll go for 100 billion, and then trillion. Sounds good. All right. Any closing thoughts? We have exactly 1%